Good afternoon, everyone. Today we are going to discuss the topic cross product. Cross product is a binary operation on two vectors in three-dimensional space. It results in a vector that is perpendicular to both the vectors. The vector product of two vectors A and B is denoted by A cross B. Cross product of two vectors. The vector product or cross product of two vectors A and B is denoted by A cross B, and its resultant is perpendicular to the vectors A and B. The cross product is mostly used to determine the vector which is perpendicular to the plane surface spanned by two vectors, whereas the dot product is used to find the angle between two vectors or the length of the vector. The cross product A cross B is equal to another vector at right angles to both, and it happens in three-dimensional space. Cross product formula. If theta is the angle between the given two vectors A and B, then the formula of the cross product of vectors is given by A cross B equal to determinant A into determinant B into sine theta, or A cross B equal to modulus A into modulus B sine theta n cap, where A and B are the two vectors and mod A and mod B are the magnitude of the given vectors. Theta is the angle between the two vectors. The n cap is a unit vector perpendicular to the plane containing the given two vectors in the direction given by the right hand rule. Cross product of two vectors formula. Consider the two vectors A equal to AI plus BJ plus CK and B equal to XI plus YJ plus ZK. We know that the standard basis vectors I, J and K satisfy the below given equalities, that is I cross j equal to k and j cross I equal to minus k, j cross k equal to I and k cross j equal to minus I, k cross I equal to j and I cross k equal to minus j. The anti-commutativity of the cross product and the distinct absence of linear independence of these vectors signifies that I cross I equal to j cross j equal to k cross k equal to 0. Now, A cross B equal to AI plus BJ plus CK cross XI plus YJ plus ZK, and it is given by AX into I cross I plus AY into I cross J plus AZ into I cross K plus BX into J cross I plus BY into J cross J plus BZ into J cross K plus CX into K cross I plus CY into K cross J and CZ into K cross K. By applying the above mentioned equalities, A cross B is equal to AX into 0 plus AY into K plus AZ into minus J plus BX into minus K plus BY into 0 plus BZ into I plus CX into J plus CY into minus I plus CZ into 0, which is equal to BZ minus CY into I plus CX minus AZ into J plus AY minus BX into K. The cross product properties. The first property is the anti-commutative property, that is A cross B is equal to minus B cross A. Second one is the distributive property, whereas A cross B plus C equal to A cross B plus A cross C. Third one is the Jacobi property, represented as A cross B cross C plus B cross C cross A plus C cross A cross B equal to 0. The zero vector property is denoted as A cross B equal to 0 if A equal to 0 or B equal to 0. Cross product of perpendicular vectors. The cross product of two vectors is equal to the product of their magnitude, which represents the area of a rectangle with sides x and y. If two vectors are perpendicular to each other, then the cross product formula becomes theta equal to 90 degrees. Therefore, x cross y equal to mod x into mod y into sine theta, that is equal to mod x into mod y into sine 90, where sine 90 equal to 1. Therefore, mod x into mod y equal to x cross y, which is equal to the area of the rectangle. Cross product of parallel vectors. The cross product of two vectors are zero vectors if both the vectors are parallel or opposite to each other. Conversely, if two vectors are parallel or opposite to each other, then their product is a zero vector. two vectors have the same sense of direction, theta equal to 90 degree. As we know, sin theta equal to 0, sin 90 equal to 1. So x cross y equal to mod x into mod y into sin theta, that is equal to mod x into mod y into sin 0, that is equal to mod x into mod y into 0. Therefore, the cross product x cross y equal to 0, which is a unit vector. Thank you.